Now let's get some, more definitions. Closed sets. This is pretty easy. The definition of a closed set, how do you define it? Well, if your X tau is a topological space, and A is some subset of X, and we call A closed or closed if X minus A belongs to tau. This is called the complement of A, and it belongs to tau. That means the complement of A is open. So to show that a set is closed, all you need to do is to find out its complement and show that it belongs to the topology. Then you are done. That's how you define closed sets. With that, we can also define something called a closure of a set. So let me just call it closure over here. The closure of a set of A, that is some set, is the smallest closed unit, is the smallest closed, I'm calling it a unit. Since you are working with sets, you can call it a set as well. So this is the smallest closed set that contains A and it is written or denoted as some A tilde. And then when you talk about closed sets, you can also talk about the interior and the boundary as well.
Does A has to be closed or open or anything? Like
Mm,
A is arbitrary, right?
no,
Like
no,
an
no. A has to
arbitrary.
be A has to be closed first, because you are talking about closed set, right? We're talking about closed sets. So the
So we
closure of
can
A.
so
Okay.
we can
Sorry.
define closure only on closed sets.
A is closed. First, you have to define this, and then you can define the closure of the set. Okay. And since we're dealing with closed sets, it only makes sense to talk about interior and boundary points. For open sets, that doesn't make any sense. Boundary, because open set doesn't have any boundary, or open ball, it doesn't have any boundary. So let's define interior.
Sir, if A, I mean would you scroll up a bit?
Okay.
Closed sets. So if if A was if A was open, wouldn't X minus A would still be in tau?
Did I tell anything about, did I just said anything about A being open? No, I said if you want to prove that A is a closed set, then you have to show that the complement is open.
Oh, I get it.
It's at first you start with some arbitrary A, and you want to show that this is closed, right? If it's open, there is no point in trying to prove it to be closed. Do you get my point?
Yes, sir. And what is closure? I didn't get that.
It's the smallest unit of A that is closed, and it contains A, and it is denoted with some A tilde. People write it like that.
Like does the closure has to be unique? Like একটা সেটের কি একাধিক ক্লোজার থাকতে পারে? Like you said smallest unit, এখন এই smallness measure করবো কেমনে in terms of what number of elements, or I don't know. Like how do you measure this like smallness?
How do you measure the smallness? I think I have to look up Manifest to answer this question. I don't remember it right now.
Okay.
So talk about one
সাব
phrase.
মানে যদিও ইউনিয়নটার যে ইয়েটা মানে মানে ক্লোজার আর ওই সেটটার ইউনিয়ন মানে যেটা সাবসেট দেয় মানে সাবসেট দিয়ে কিছু করা যেতে পারে যে ক্লোজ সেটটা আর আহ, মানে ওপেন থেকে ক্লোজ করার সময় সব লিমিট পয়েন্ট ইনক্লুড করতে হয় না তো
Hmm.
আহ, মানে জাস্ট মানে দেখাতে হবে যে মানে ইকুয়াল যে ওটা মানে উভয় পাশে যদি এমন হয় যে জাস্ট মানে লিমিট পয়েন্ট ইনক্লুড করার পর যেটা হয় ওটা হচ্ছে ওটা সাবসেট বাট নট দি আদার ওয়ে অ্যারাউন্ড তাহলে মেবি স্মলেস্ট না
স্মলনেসটা ইউনিক কিনা এটা বলতেছো?
মানে ক্লোজার ইউনিক কিনা আমার কোশ্চেন ছিল ওটা আর কি।
ক্লোজার আই থিংক ইট শুড বি ইউনিক।
আর
let's
এখানে যে বলা হয়েছে যে স্মলেস্ট ইউনিট, এই স্মলনেসটা কিসের ভিত্তিতে আমি বুঝবো? লাইক
just like Niam said,
লিমিট
you have
পয়েন্ট দিয়ে
limit points.
আচ্ছা
That's why
মানে
I don't want to go into details because I'm not teaching it
রুডিনের
based on
বইয়ে
here.
এটা ইয়ে করা ছিল রুডিনের সেকেন্ড চ্যাপ্টারে
So yeah, it will involve things like limit points. How do you do those things? It will involve basis. And the rabbit hole goes deeper and deeper.
Acha,
So
when you say unique, are you saying that like there could be two different things that represent the closure? They're both smallest because they're equal in size. Is that what you mean by unique?
না মানে
Nahi,
ইউনিক
I think
মানে একটাই আর কি।
was that question mentioned for Nahi? Like Nahi, is
Yeah.
that what you meant by unique?
no,
Then
I meant like there, whether there can be more than one set that could represent as a closure
okay,
of
let
A.
so what Nian said is that to make a closure, or you have to include all the limit points, right? So if you find that, let's say this is one, let's say these are my limit points like this, and this is what I draw, right? So this is, I think this should be your some intuitive idea of how you measure the smallness or the smallest unit. Let's say this is the closed set, okay? This is the closed set, and you have some subset that includes all the limit points. So this guy is the closure. If you consider something more small, it doesn't include all the limit points, right? Do you get my point, what I'm trying to say? Okay, Nahi, what you should do, you should look at Mancres in the chapter, I think chapter 2, if I remember correctly, limit points. There they have some discussion on closure as well. Okay, if this geometrical picture or this intuitive thing doesn't make any sense to you, just consult Mancres. They have a very rigorous proof of whether they're unique or not. But yeah, I think it should be unique. What Neon was saying, perhaps it's right. It should be unique. Because if you consider something more smaller, that won't contain all the limit points, right? And if you consider something bigger, then what's the point of saying that this is the smallest unit, right?
এটাই
Because you can make a smaller unit that contains all the limit points, right? Like close set, this is one unit, this is another unit, and this is another one. So this unit, it carries all the limit points, but it contains all the limit points. This unit again, it contains all the limit points, but you can make it even smaller. But this is the smallest guy, but it doesn't contain all the limit points, right? So these two things are not really, they shouldn't exist. I mean, we don't need them. So this guy should be unique. But again, for a rigorous treatment, go to Mancres, and I think Nian was right. But still, if you find something different, do share in the next class or in Slack. That would help me out even. Okay, so let's talk about some more definitions, because this chapter is all about definitions. And we want to define something called an interior and a boundary. So where was I? Okay. The interior of some closed set A, the interior of A is the largest open subset of A. The largest open subset of A. And people write it as this A to the power 0 or something, like it's similar to this angstrom symbol, but this is the definition: the largest open subset. Okay, a closed set, the set A itself is closed, but within that closed set you can define some subsets, and the biggest subset, or so to say the largest subset which is open, is called the interior. And you can think of it like this. Let's say this is a circular disk. So even though this drawing is not accurate, this distance is very, very, very small. This is your interior, and this is in fact the boundary. And let's define what is boundary. The boundary of A is the complement of A0. That means it's the complement of the interior. So how do you write it? You just write it like this. This is your boundary. And I think it should make some sense from this figure. Like, it goes all the ways up to, it doesn't touch the boundary, but this whole thing is your set A, this is your interior, and this is the boundary, which is just the complement of A0. Okay, any questions?